Hi students, so it was a grand success this round. uh, 0.8 trial 2, totally 103 students have participated, and there's a big variation in the scores also. One student has got 10 on 10 in MCQs, but I have to watch the video explanations yet. As you know, the scoring is such that if the MCQ is correct but video explanation is wrong, you lose 5 marks. If the MCQ is correct and video explanation is also correct, then you get plus 5 points. So let us see what will be the final score of all the students. In the meanwhile, I thought you'll be curious to know what is the correct answer and the correct explanation both. So I'm just made this video to explain the correct explanation along with the correct answer. So here goes. First question. So in this question, what happened to the mass and to the weight? Now see, you are having flexible material. Think of it like sponge. So sponge initially has pores which are filled with air, and that air is at atmospheric pressure. So by compressing the sponge, you make it into a smaller volume, so the density of the sponge will increase, but the mass remains the same. The amount of matter in the sponge remains the same, and so even though density increases, the mass remains the same, and so the weight is mass times gravitational field. Gravitational field remains the same at the same location of the Earth, so weight also remains the same. So the answer is D, no change. Clear? Okay, how is my stylus? I will connect my stylus. So option is D. Moving on to the second question. A compressed spring projects a ball horizontally. Okay, so here the compressed spring will give the same, will have the same behavior even on the moon as on the Earth. And on moon also it's vacuum, no atmosphere. So there is no air resistance even in the vacuum chamber on Earth and on moon. So the horizontal velocity with which the ball is launched will remain unchanged due to the spring. So for example, if this is a spring, the ball will get the same horizontal velocity. But then after that, it will travel in the vertical direction with some acceleration due to the gravitational field. And so on Earth, the acceleration to the gravitational field is 9.8 meters per second squared. On the moon, it is 1/6 of this. So on the moon, its downward motion will be slower. It will increase at a slower rate. So it will cover the downward distance lesser amount in the same time. So the time of flight will increase on the moon, and so on the moon the ball can travel a much greater distance. So it starts out with the same speed and it will travel a more greater distance. So the answer is the horizontal speed is the same and the ball is therefore more than 4 meters in front of the speed. So D. Next question. So when you have identical cells in parallel, okay, the voltage cannot change. So then why do we connect them? We still connect them because the chemicals which are setting up the voltage difference will now be more. So earlier if there was some m grams of chemical, now there are 2 m grams of chemical. So the batteries will last for a longer time. So suppose this is the resistance. So the current will last before the battery drains out for twice the time. So the battery lasts longer than a single cell on its own. So C is the answer. Now this one is a tricky question. So as you can see from this diagram of the question, say this free body diagram of the book, all the forces acting on the book means free body diagram of the book. So along vertical direction net force is 0, so it will have no vertical motion. And in the horizontal direction, the only external force acting on it is frictional force, right? And frictional force is being exerted on the book by the table. And friction force arises whenever there is a relative motion between two surfaces or there is a tendency for relative motion between the two surfaces, two cases. So here obviously there is no relative motion between the two surfaces. That means there is a tendency for relative motion and friction opposes it. So that means the table is trying to move towards the right and the friction is acting on the book to prevent it from moving to the left. But why would the book try to move to the left? The book has inertia of rest. So if the book tries to remain at rest due to its inertia of rest and the table is already moving to the right because it is part of the train which is moving to the right. So if the train is accelerating, table is accelerating along with the train, then the book will try to get left behind. So the relative motion is tending towards left for the book. So friction will arise and oppose this tendency to move left and it will act to the right. So which means the train is accelerating to the right. So how is the train moving? Accelerating to the right of the diagram. Then this is a good one. Specific heat capacities of aluminum, iron, ethanol. Okay, now see here. The mass is fixed, 5 kg, 1 kg. So metal mass is fixed, mass of liquid is also fixed, initial temperature of metal is also fixed, initial temperature of liquid is also fixed. Okay, so you have 4 cases A, B, C, D, which are obtained by 4 ways in which you can put the blocks in the different liquids. Now you want to know which example has the highest final temperature. So when you put a hot object into a there is a transfer of heat from the hot object to the cold object. So let's call that heat as Q. So due to this transfer of heat, the initial temperature of hot object, T initial of hot object will go to final temperature, say T. So this T can be temperature for option A, B, C, D. So this can be A, B, D. And the cold object also will rise to the same final temperature. So initial temperature of cold object will go to the same final temperature of say TA, TB, TC, TD. Now our question is, this final temperature is highest in which case? So if it is highest in a particular case, that means the hot object should lose the temperature minimum and the liquid should raise its temperature maximum, but the transfer of heat is same. So for the same heat loss Q, the metal should lose less temperature, but liquid should gain more temperature. Whichever case it happens maximum, that is what we need. So now, if metal has to lose less temperature, the specific capacity is the amount of heat required to raise the temperature or lower the temperature by unit value for unit mass. And the mass is same for both the metals as well as both the liquids. So it comes down to temperature difference. So if you want, so if the specific heat is high, then for the same small TQ for the same heat energy Q, the temperature change will be less for the metal. So out of these two metals, which has highest specific heat capacity? This one. And now we want liquid to raise its temperature to maximum value as close as to this T value, which is close to the hot object's temperature. So it should have a low specific capacity. So the same heat, when it is given to the mass of liquid, it raises its temperature by large amount. Because heat required to raise its temperature by unit value is less. So out of these two, which is less specific capacity? Obviously water. Ethanol. So 900 and 2400. So aluminium and ethanol is the answer, which is option A. Next. This is a tricky one. See, in this actually the concept which we are using is Snell's law of refraction. And if you have, say, medium 1 and then medium 2 and then medium 3, okay, and let us say light is refracting from medium 1, and let us draw the normal in green, and depending on the refractive index of each medium, light will bend. So let us say medium 1 has refractive index m1, medium 2 has refractive index m2, medium 3 has refractive index m3, and there is some relation between these three mediums. Let us say n2 is less than n1 and n3 is less than n2. So if the refractive index becomes less, that means the speed will be higher. So if the light is going to speed up in the second medium, the angle of refraction will be greater. It will bend away from the normal. So whenever it speeds up, it bends away from the normal to the point of incidence. So let us say it goes like this. Okay. Now the new normal here is at this point of incidence, and now again the refractive index is less than the previous, so it will again bend away from the normal. So with respect to the original direction, it will bend away from the normal even more. So like this. So now how do you relate these angles? The angle which the ray makes with the normal in that medium is called theta. So in medium 1 is called theta 1, in medium 2 is called theta 2. So similarly here also we have that green line. So this angle will be angle of the refracted ray with the normal in medium 2 will be called theta 2. In medium 3 your refracted ray here and your normal like this. So this angle will be theta 3. So Snell's law of refraction tells you the relation between the angle of incidence or refraction in each medium, how they are connected. So it's actually n1 sine theta 1 is equal to n2 sine theta 2 is equal to n3 sine theta 3 and so on. So the basic concept to understand here is if n1 is big, the angle will be small. If m2 is small, the angle will be big. And it doesn't matter what the in-between medium relation is. This and this relation will always hold. So in this case, though you have a layer of liquid, even if you remove the layer of liquid, whatever you have the relation between glass and air, that relation will still hold after adding the layer of liquid also. So we have said in the question that for glass and air, if you call this as N1 and this is N3, the theta 3 is 90 degrees and theta 1 is the critical angle. So you call it critical angle. So now in between you put liquid. So it will create a, so the liquid will be N2 theta 2. After that, when it goes back to air, you will have N3 theta 3. So automatically theta 3 will again become 90 degrees because the refractive index of air is N3, which is In this case, maybe say it was 1. So 1 and 90 degrees have to be there. So the resultant will be again same as the original diagram. So it has to be option D. I hope it's clear. Seventh question. A wave on a... Okay, so this one, you have to understand that when a wave travels to the medium, there are three aspects to it. One is the particle is vibrating in the same position. It doesn't have any, the particles do not move through the medium. The wave moves carrying energy but not matter. So in a transverse wave, the particle only goes up and down. So option C and D are automatically wrong. So now you have to choose between A and B. And the wave is traveling forward. So you have this relation that as time passes for a single particle, the time which has passed is a fraction of the total time period of vibration of the particle. And the phase which it has covered. So one time period is considered to be one complete cycle of vibration, to and fro motion. And one cycle of vibration is denoted by a circular motion in which a particle covers 360 degrees or 2 pi radians. So corresponding to the time which has elapsed, it would have covered a fraction of the circle. That angle is called the phase angle phi. And if you consider the distance traveled by the wave in one time period or in one cycle of complete vibration, the wave travels a horizontal distance of one wavelength, lambda. So corresponding to time period, you have lambda. Corresponding to the time, it will actually travel some distance x. So now let us use this relation to answer the question. So what is the position of the marker? That means at this marker is vibrating up and down. Where would it be in its cycle of motion, oscillation, after time of 1 by 4f? So now time period is 1 by f. So let's calculate t by time period. So it is equal to time is 1 by 4f divided by, now time period is 1 by frequency. So 1 by f will cancel out with 1 by f, and you are left with 1 by 4. Okay. So now if you compare this 1 by 4 with the fraction of the phase of oscillation, it's 5 by 2 pi. So phase of oscillation which has happened is 2 pi by 4, which is pi by 2. Now 2 pi means one complete oscillation, pi means half oscillation, and pi by 2 means 1/4 oscillation. Or in terms of distance traveled, 2 pi means one complete wavelength, and pi by 2 means 1/4 wavelength. So the marker is here, the wave is here. So from here to here is, this distance is corresponding to pi phase change, and this distance is also corresponding to pi phase change. So half of that is pi by 2. So the wave is traveling forward. This position would have come here. So the wave would have become like this. Okay. So that means the new position of the marker would be at A. So A is the correct answer. By the way, I understand I had asked you guys to finish your explanation in 5 minutes, and I myself have taken almost 20 minutes till now. Okay. Now in this question, you have to find which combination will result in both bulbs being illuminated. So if you don't close this switch one, current will not go into this rest of the circuit. So this has to be closed, and if you close this, then it will short circuit this bulb. So current will not flow through this. So current takes the path of least resistance. So this should be open, and if you want this one to glow, this circuit has to be closed. And then if you close this, this will short circuit this bulb, because current will not flow through this bulb, it will flow through this wire only. So this should be open. So switch 1 and 2 should be closed. So 1 and 2 should be closed, 3 and 4 should be open. So close, open, so option C. Then now here you see, at each point it is the bottom of the hill, first hill. So this is speed time graph. So speed starts from rest and it just moves along the hilly road without using pedals or brakes. So he doesn't apply any force. He just goes on his own. So gravitational force is doing the work. So he is going downhill. So speed is increasing because he is going downhill, and it becomes flat because he is on a horizontal hill surface. So kinetic energy doesn't increase. That means gravitational potential energy also doesn't decrease. That means height doesn't decrease. Then suddenly the kinetic energy is increasing because speed is increasing. That means gravitational potential is decreasing. That means height is decreasing. So this is the lowest point. So this is the bottom of the first hill. But this, his speed starts decreasing, which means kinetic energy starts decreasing, which means potential energy starts increasing, which means mgh starts to increase. So he is again going uphill. So B is the correct answer. Last question. So in this, what happens is, copper is a good conductor of heat, wood is a bad conductor of heat, it's an insulator. So when you heat the center of the rod on which a paper is tightly wrapped or stuck on it, the copper part will conduct the heat away from the paper and prevent it from reaching the ignition point to catch fire. So it won't burn, don't start burning. But the wood is a bad conductor, so the heat is trapped. It can't go away. So the paper above the wood will start getting hotter and it will start burning. Since you let the fire only for a few seconds, it won't burn completely, it will just partially burn, it will become brown. So which side goes brown? Obviously the wood side, and wood is an insulator and copper is a conductor. So D. So that completes it. Okay.